Hello, I'm Sebastian. Welcome to 9 Trees podcast. Today, I will summarize and review the book. Code by Charles Petzold is a classic, reader-friendly tour of how computers work, starting from simple ideas and building toward modern hardware and software. Rather than assuming a technical background, the book develops computing concepts through everyday analogies such as switches, signals, and symbolic systems, showing how complex machines emerge from basic components. Petzold connects the physical world of circuits to the logical world of representation, arithmetic, and instructions, explaining how information can be encoded, stored, transformed, and communicated. The result is an accessible map of the hidden layers beneath programming languages and operating systems. Many readers value the book because it explains not just what computers do, but why their design makes sense, from binary numbers and logic gates to memory, processors, and the earliest forms of code. It is a foundational read for anyone curious about computing from the ground up. I will give you key takeaways from this book. Firstly, from signals to symbols, communicating information, the book begins by grounding computation in communication. Before chips and software, there is the problem of representing meaning using physical phenomena. Petzold explores how a system can encode information with simple on and off states, and how constraints like noise, distance, and reliability shape the design. By tracing a path from basic signaling to structured symbolic alphabets, the reader sees why standardized codes are essential for interoperability. This framing clarifies that computing is not magic, it is disciplined representation. A key takeaway is that every digital system depends on agreed mappings between symbols and states, whether those symbols represent letters, numbers, colors, or instructions. Understanding encoding helps explain later concepts like bytes, character sets, and data formats, and also makes modern topics such as compression and error detection feel intuitive rather than mysterious. The topic also highlights an important mindset: hardware and software cooperate to preserve meaning across transformations. When you grasp how meaning survives through layers, you become better at debugging and system thinking, because you can ask where representation might be ambiguous, lossy, or misinterpreted. Secondly, binary thinking, numbers, arithmetic, and data representation, a central thread in code, is how binary becomes a practical foundation for representing numbers and performing arithmetic. Petzold breaks down positional notation and shows how counting in base 2 mirrors familiar decimal ideas, just with different place values. From there, the discussion naturally extends to how addition, subtraction, and other operations can be mechanized. The broader lesson is that data is not limited to numbers. Once you understand that any information can be encoded numerically, you can see how text, images, and sound ultimately become patterns that hardware can store and manipulate. This topic also helps readers understand limits and trade-offs, such as finite ranges, overflow, precision, and why certain representations are chosen for efficiency or simplicity. Even without heavy mathematics, the reader gains a durable intuition for bits, bytes, and how higher-level abstractions depend on low-level representation. That intuition pays off when reading about memory layouts, file sizes, performance, and the practical consequences of design decisions in programming languages and computer architecture. Thirdly, logic gates. Building reasoning from simple components, Petzold shows how logic emerges from electrical switching. By combining basic components that implement simple rules, a system can perform increasingly sophisticated decision-making. The progression from elementary operations to compound behavior demonstrates a core principle of computer engineering. Complex logic can be constructed from a small set of primitives. Readers learn why gates such as AND, OR, and NOT matter, and how their combinations can represent conditions, comparisons, and control. This is not presented as abstract theory alone. The explanations connect physical circuits to logical truth tables, showing that hardware can embody logical relationships directly. The topic also introduces the idea of composition, where small reusable blocks are combined to form larger units, an idea that later parallels software functions, libraries, and modular design. By the end, the reader can see how a computer is not a single monolithic invention, but a layered construction of understandable parts. This perspective helps demystify terms like combinational logic, control signals, and state, and it builds confidence for exploring electronics, embedded systems, or lower-level programming. Fourthly, memory and state, storing information over time. Computation requires more than moment-to-moment logic. It needs memory, a way to hold results, represent state, and enable sequences of operations. Code explains how storage can be created from logic elements and feedback, turning transient signals into persistent information. This topic clarifies why memory is central to everything from counting and calculation to running programs. Petzold explores how memory can be addressed and organized, leading to the concept of locations that can be read and written. The emphasis on addressing and structure helps readers understand why software talks about variables, arrays, and pointers, and why hardware talks about registers, RAM, and buses. The reader also gains a sense of the hierarchy of storage and the engineering compromise between speed, cost, and capacity. Understanding state makes it easier to grasp how systems keep track of where they are in a process, how they respond to input, and why certain bugs occur when state changes unexpectedly. This topic forms a bridge between the physical machinery and the abstract idea of an executing program. Lastly, from hardware to software, instructions, processors, and abstraction, the later arc of the book ties the earlier building blocks into the concept of a programmable machine. Once a system can store numbers and apply logic, it can interpret stored patterns as instructions. Petzold explains the idea of an instruction set and how a processor can fetch, decode, and execute operations in a cycle, turning electrical activity into purposeful computation. This topic illuminates how software is layered on top of hardware through abstraction. Machine-level operations become assembly-like concepts, which then support higher-level languages and operating systems. Readers come away understanding why compilers exist, what it means to execute code, and how the same hardware can run radically different programs by changing the stored instruction stream. The emphasis is not on memorizing specific opcodes, but on understanding the model of computation that makes general-purpose computers possible. This knowledge helps readers reason about performance, constraints, and portability, and it provides a mental framework for exploring systems programming, architecture, and the foundations of modern software development. In conclusion, this book is best for curious beginners, new programmers, product managers in tech, and anyone who uses computers daily but wants to understand what is happening underneath. It is also valuable for experienced developers who never studied hardware fundamentals and want a clear mental model of the layers below high-level code. The benefit to your life is practical. You gain the ability to reason about technology instead of treating it as a black box, which improves troubleshooting, communication with engineers, and informed decision-making about tools and systems. Compared with many computer architecture texts, code stands out for its narrative clarity and its step-by-step construction from simple ideas to powerful outcomes, without requiring advanced math or prior electronics knowledge. It focuses on intuition and conceptual coherence, making it easier to retain and apply. If you want a single book that connects signals, logic, memory, and software into one understandable story, it is worth buying because it delivers lasting understanding rather than short-lived tips. If you would like to support Charles Petzold, you can buy the book through the Amazon link I've provided in the podcast description. After reading the book, please let me know what you think and share your thoughts. See you around.